Okay. Okay. In this presentation, I will talk about hypergraph cognitive networks, and as the title says, I want to give you some insights towards these new directions, this new possible direction of research in cognitive science by using higher order representations for complex systems, in our case, human mental lexicon. We are trying to merge or at least use two different types of contexts of research. The first one is the one of cognitive network science, where researchers want to use network science tools, methods, measures, representations, and models to study human cognition, human mental lexicon, semantic memory, in decades of researches, several types of complex networks have been used in several studies, from multiplex and multi-layer representations to attributed networks representation. But of course, this type of networks are pairwise, are made of pairwise interactions between nodes. And the second context of research we want to use is, of course, the new one of higher order networks, where researchers want to use to focus not only on pairs of nodes, but on sets of nodes or higher order interactions between nodes to model, to represent connectivity between nodes and interactions and links as hyperlinks, for instance, in the hypergraph representation. This presentation, is based on two works going towards these directions. For a matter of time, I will just focus on one of them. And in this work, our goal is to predict word concreteness based on aggregated feature values, where these aggregations are based from several types of graph and hypergraph representations of free associations. The motivation of these works is because clustered words, networked words, and concepts are very important. Very important representations, and we have similar concepts in the literature. For instance, the idea of patches in foraging studies, in studies on searching memories. And that's why we want to use this new higher order context, this new higher order words to represent hyperlinks as memory patterns. So in this work I'm going to present, we use the data from the small world of words dataset. So we are using the free association games, where we know that a keyword is presented to a user, and the user will respond with the first three words that came in the mind. And several previous works studied the structure and function of these free association networks by using a pairwise graph representation, where the keyword is connected to the first response, or the keyword is connected to all the three responses, but in a pairwise way. So we believe that a more natural, naive, and simple way to connect at the same time the keyword with its three responses is to use an hyperlink, is to represent it as a set of words. And in this work, we are also using some labels on nodes. So each node is labeled as a vector of psycholinguistic variables among valence, arousal, dominance, age of acquisition, semantic size, and of course concreteness, which is our target variable to predict. Just to give you an idea of what we mean for aggregating features, let us consider this toy example, where let's assume we want to predict the concreteness of the word dog based on information about the length. So in a simple way, in a simple strategy, we can use the real dog length, which is 3, to predict the word concreteness. But assuming the assortative mixing hypothesis, and we want to label each word with an aggregation based on information about the graph or hypergraph representation. For instance, if we use the average value of the length of the ego network of the adjacent neighbors of words from 3, it became 4.4 for the words dog, for the word dog. And of course, we want to leverage more complex aggregation strategies from ego network, from local network communities based as well on a pairwise graph interaction, and of course we want to leverage the hypergraph aggregation to label features on to label words with average feature values. This is a visualization of the real network, of the real data we are using. The first column represents no aggregation at all, and the other 3 columns represent the ego network strategy, the local network community based on the pairwise network, and the hypergraph interaction. And the hypergraph aggregation. This means that, for instance, let us consider war and love that have high semantic size, but a positive valence for love and a negative valence for war. Of course, these 2 words have different values in the different aggregation strategies. And our idea is to predict word concreteness based on these feature values, on these aggregated feature values. So we performed our common machine learning supervised approach, basically a regression where we want to predict the real word concreteness based on those aggregates. And we used a random forest regressor on each aggregation. So the column represents different aggregation strategies, and we evaluated the performance of the regressor of the random forest regression based on mean squared error and R squared measures. And we found that the regression on the hypergraph strategy is better than the other ones, is slightly better than the ego network and the non-network strategy at all, and is better than other community detection strategy based on global communities or local ones, global like Louvain, local like Lemon. Just to give other insights about this analysis, of course, we are using a random forest regressor, so we can also use unexplainable AI methods for identify which kind of patterns are better predicted than others, and we've basically discovered, for instance, that early acquired words are better predicted than other words having a low semantic size are better predicted than other, and so on. In this plot, we also show that the predictions, the patterns of prediction based predicted by all the aggregation strategies are basically similar. So the gray zones here are the values that are better predicted, are the words that are better predicted, of course, in terms of concreteness. So the idea is the hypergraph representation is better than others, but in predicting the same patterns of words, the same concreteness of words. So to conclude, what it means to achieve better results in an aggregation strategy than we respect better rather than the other aggregation strategies. The idea is that the associative knowledge in the mental lexicon form some kind of clusters, some kind of networks and networked words which are very useful in in age of acquisition, I guess, or is based on the works uh, I didn't mention in this presentation, or in terms of concreteness in the works I presented here. Of course, these two works, in particular the one I presented in this presentation, are just some preliminary ideas, some preliminary tasks of research going toward the direction of using higher order networks in the study of cognitive networks. So we can have several other tasks that we can leverage by using this kind of representation in the future.